Okay, particle motion for your response questions. The majority of the time, these are parts that are inactive, but not always. So just keep that in mind. On this one, we've got the time range from 0 to 12. A particle is moving along the x-axis. The velocity of the particle at time t is given by the cosine function. The particle is at position x equals -2 at time t equals 0. So remember what I've been trying to emphasize recently. Anytime they give you information like this, you're probably going to use it at some point in time. If you don't use it, you better go back and check and make sure that you're not missing somewhere where you should have used that information. Now let's look at part A. Between time 0 and 12, when is the particle moving to the left? When is the particle moving to the left? So particle moving to the left, you should be thinking velocity is negative. Okay, particle moving to the left, or if it's on the y-axis, that would be moving down. That means your velocity is negative. If it's moving to the right or it's moving up, then your velocity is positive. So we're given velocity function. So we're going to set that equal to 0 because we need to find critical points. We need to know when it's changing to be able to figure out when it's moving to the left and to the right. Okay, so let's first of all, we got to think about when is cosine equal to 0. So cosine is the x-coordinate on the unit circle. So on the unit circle, your x-coordinate is 0 at pi over 2 and at 3 pi over 2. Now, I'm not saying that that's equal to t because it's not. It's equal to pi over 6 times t. So we have one more step before we can solve for t. We got to multiply both sides by 6 over pi. So pi's cancel, 6 over 2 is 3. So 3 is one of our times when the particle is at, where the velocity of the particle is 0, meaning the particle is at rest. That may come in handy later on. And if we multiply this other one by 6 over pi, we're going to get, let's see here, pi's cancel, 6 times 3 is 18, 18 divided by 2 is 9. Okay, so at times 3 and at times 9, the velocity is 0. We get 1 point for considering that, that the velocity is equal to 0, but that's not the answer. Okay, remember, be careful when you find these intermediate answers, you're actually answering the question. Was the particle moving to the left? So we start at 0, we end at 12, we've got 3 and 9 is when it's at rest, so we've got to test some numbers here. I don't know, 1, 5, and 10 sound good to me, okay? We're plugging this into our velocity function, because remember, we want to know the sign of the velocity. So the velocity, when we plug in 1, that's the cosine of pi over 6. I don't care what it is. I'm just wondering whether it's positive or negative. Pi over 6 is in the first quadrant. Cosine is positive in the first quadrant. Okay, and the next one, cosine of 5 pi over 6. 5 pi over 6 is in the second quadrant. Cosine is negative in the second quadrant. And cosine of 10 pi over 6, 10 over 6 reduces to 5 over 3. 5 pi over 3 is in the fourth quadrant where your cosine is positive. So the particle is moving to the left. For 3 is less than t, which is less than 9. So you get 1 point for just setting your velocity function equal to 0, and you get 1 point for your interval here between 3 and 9. Remember, I don't think they get super crazy about it, but don't include 3 and 9 because that's where it's changing. It's not moving to the left at times 3 and 9, it's changing position or it's changing direction at times 3 and 9. So if you write it like that, or if you write it in interval notation, make sure you use parentheses and not brackets. All right, part B, write but do not evaluate. I love these questions because you're totally off the hook. Like, you just have to set it up. You don't have to figure it out. You just need to set it up. So let's keep going. An integral expression that gives the total distance traveled by the particle from time 0 to time 6. So 2 keys here. Total distance traveled. Okay, total distance traveled should make you think absolute value, because you're wanting to find out, it's like when I start my day when I come to school. Okay, I park in the parking lot. I have to walk to the office. I have to walk from the office to my classroom. During the day, I may walk from my classroom to the copy machine and back to my classroom. I need to go to the restroom at some point in time, so I have to go to the bathroom and back to my classroom. And then when I leave, I always leave my classroom, go back to the office, check to see if I need anything, and then I walk back to my car. Well, I'm ending up back where I started, right? Everywhere I kind of retraced my steps. So my displacement in that case is 0. I ended up where I started at the beginning of the day. But that's not my total distance traveled, okay? My total distance traveled includes every step that I took. So, those cases where I'm backtracking, when I go to the copy room and come back to my classroom, it's the same amount of distance there, but one of those has got to be considered as negative distance. But if I'm talking about total distance traveled, I got to take that negative distance and make it positive. So hopefully that helps you think about that. All right, and then the other detail we got to pay attention to is the actual times. Okay, the whole interval is from 0 to 12. This just says from 0 to 6. And this is a 1-point part of your question that could be made or broken by messing up the time intervals. You can get the absolute value part right, but if you don't put the right limit on your integral, you're gonna mess up there. Okay, so from 0 to 6, integral from 0 to 6 of the absolute value of the velocity function with respect to time. Remember, the accumulation of velocity gives you distance. So again, 1 point. You got to have all those pieces right. So the part C. So we've got, 3 points so far? So that means we've got 6 points left for C and D. That's pretty heavy. Find the acceleration of the particle at time t. So let's just find that part right now, okay? Acceleration is the derivative of velocity. So for velocity, I'm going to start by copying it down. Okay, so velocity is equal to the cosine of pi over 6 over t, or pi over 6t. So acceleration is the derivative of my velocity. So the derivative of cosine is negative sine. And don't forget to take the derivative of the angle. So that's pi over 6. So this final answer would be negative pi over 6 sine of pi over 6t. So we get 1 point for the acceleration function. All right, so we're not done. Look back at the question. Is the speed of the particle increasing, decreasing, or neither at time equals 4? Explain your reason. Okay, so for some reason we're kind of struggling with this, but don't forget, speed, yes, it's the absolute value of your velocity, okay? But if they're asking you, is it increasing, decreasing, or neither at that time, they're asking you to compare the signs of velocity and acceleration at that time. And wouldn't that kind of make sense? Why would they ask you for the acceleration, to find the acceleration function, and then ask you that question right after that, okay? They're kind of sort of giving you part of the answer. So V of 4, again, we don't care exactly what the value is, okay? We do not care exactly what the value is, we're just concerned with whether it's positive or negative. So 4 pi over 6 reduces to 2 pi over 3. Either way you want to look at it, it's in the second quadrant where cosine is negative. Okay, and A of 4 is equal to negative pi over 6 times the sine of 4 pi over 6. Sine is positive in that quadrant, but we're multiplying it by this negative number, so that answer is going to be negative. So our answer is going to be, since velocity and acceleration have the same sign, at t equals 4, the particle, the speed of the particle, excuse me, always be specific, the speed of the particle is increasing. this time. Remember, when they have the same signs, whether they're both positive or both negative, same signs means increasing. Opposite signs mean that it's decreasing. Neither would be the case where there's no acceleration. Okay, if you're not accelerating, your speed is not changing. Okay, if you are not accelerating, then your speed is not changing. Think about it in a car. Okay, yes, you mash the gas, but once you get to that speed that you want to be at, you just maintain the level at which you are holding the gas pedal. Okay, you don't push it down further. That's going to cause you to accelerate. You don't let off of it. It's going to cause you to decelerate. So that's where the the increasing or decreasing speed would come into play. So if your acceleration is 0, then it's neither. Okay. Last one, find the position of the particle at time t equals 4. Find the position of the particle at time t equals 4. So let's think about this. Where did we start? We started at -2. So S for position, S of 4 is equal to our starting point, -2, plus that was at time 0. So our integral here is going to start at 0. And we're going until time 4. And this is of our velocity function. Okay, it's of our velocity function. So, and it probably would have been helpful if I had actually written this instead of the velocity function, since I'm actually having to integrate it. If it was one of those just set up but do not evaluate, then just put the v of t. But since we're having to actually integrate, go ahead and put the function there because you need to reference it. All right, so the antiderivative of cosine is sine. Okay, technically this is a little u substitution problem. Okay, u is equal to pi over 6t, so du over dt is equal to pi over 6. Well, we don't have pi over 6 in our problem, so we got to move that to the other side. That's 6 over pi du is equal to dt. Okay, so we've got a 6 over pi here times pi over 6t, and we're going from 0 to 4. Let's leave that 6 over pi out in front for right now. So the sine of 4 pi over 6, we've been lucky up to this point. We haven't actually had to evaluate our trig. We've just had to locate where it's at. But these aren't too hard, right? The sine of 2 pi over 3, okay? So the way that I think about this is I think pi over 3, that's 60 degrees. That's my steeper angle, so sine has the greater value. So that means it's the square root of 3 over 2 versus 1/2. The sine of 0 is 1. The way that I understand it, that is a fully acceptable answer right there. Or, yeah. No, the sine of 0 is 0. My bad. I was thinking pi over 2. Whew. Sine of 0 is 0. So you can leave it right here in this form. Or if that really, really bugs you and you have to simplify it, then you would get, that's 3. And you multiply the 6 over 2 reduces to 3. And even on the rubric, well, no, on the rubric, they stop there. They don't go any further. They don't get a common denominator. Okay. So again, you can stop where I have it boxed, or you can take it one step further. Just be careful. If you do take it one step further, you got to be really, really careful that you don't simplify something incorrectly. Okay. On C, I think I forgot to mention the points. You get 1 point for your acceleration function, and you get 2 points for your conclusion with the reason. So you got to have the correct conclusion, and you have to have the correct reason. On part D, it's a 3-point part, so you get 1 point for your antiderivative. You get 1 point for using the initial condition, and you get 1 point for your answer. So the way that I understand it is if you forget the initial condition, you would lose that point, but you could still get the point for the answer if it is correct, just based on the antiderivative. Okay. So if you just had 3 square roots of 3 over pi, and you didn't use the initial condition, I think they would still give you the point for the answer.